Okay, today's lesson is about weather forecasting, and so we're going to learn about how meteorologists, like the people on the news, how they determine what the weather is going to be like and how they can tell us about that. You should all have a copy of this paper that's up on the screen. If you do not have a copy of this, please pause the video now and make sure that you get one. You're going to take all your notes from this PowerPoint presentation on that handout. So we talked about highs and lows yesterday. Remember that around the low pressure system, the air is moving counterclockwise and it's moving clockwise around the high. You're going to want to put a big star by this because this is going to be something that's on the test. It makes a difference because it tells us how the storms are going to move themselves. Remember in the high pressure system, we have the air that's descending, and so it's actually going down towards the surface, and then it's spinning. And it's because of the Coriolis effect, remember, that's why the air actually spins. That's why it doesn't just go straight down and move straight out. It actually spins as it goes down. In low pressure, this is where the area down here at the bottom is warmer, and so we have our warm air rising. Here we have our cool air that's heavier, and so it's descending. So on your sheet, you have a place to put all this information about cold fronts. Once again, you need to have your symbol for your cold front. Remember that the cold front is that area of cold air that's coming in and pushing a warm air mass out of the way. The cold front itself acts like a big wall where the warm air gets pushed up really quickly up over the top of the cold air. The air cools off as it rises, which makes it condense, and that's where we get the storms from. We get our big thunderstorms from this. Remember, these are our cumulonimbus clouds, okay, that we talked about earlier. Our warm fronts are the opposite, so now we have warm air behind the front. The warm air starts to slide up over the top of the cold air. It's not getting pushed up quite as quickly, and so it's not cooling off as quickly, which means we don't get those big cumulonimbus clouds. We're getting mostly stratus clouds and cirrus clouds as we go over, and this is the one where the rain can stretch for a long distance, simply because the front boundary is a lot longer with a warm front than it is with a cold front. And so you can get rain from this. You can also just get some of these high cirrus clouds, and that's where you're going to get some light rain showers. You can get day-long rain out of this too, but it's not going to be heavy rain. Our stationary fronts, remember this is the ones that I said that they're not moving because there's not enough difference in the temperature of the air. So it's a little bit cooler and it's a little bit warmer as opposed to cold and warm. This is the ones that are in purple here, and so it's showing that the air is not actually moving. So we can get some light winds, we can get some light rain, and whatever happens, it's going to happen for a long time while it's there until there's enough of a change in temperature that it's actually going to move the front along. Usually something else comes in behind it, either an area of high or low pressure comes in behind it and pushes it out of the way. Here's our occluded front. This is the one where we have the two areas of cold air and we've got the warm air in between, and it basically ends up getting squeezed out. So this area of cold air is not moving away as quickly as this one's coming in, and so this one just kind of pushes that warm air up, moves up really fast, and so that's why we get, once again, the cumulonimbus clouds and we get really heavy rain in here. The strong winds happen because the warm air is rising really fast. Okay, so if we were to look at our map here, and we were trying to figure out what is actually going on here, we would see that we have an area of low pressure, and storms are associated with areas of low pressure. They can be associated with areas of low pressure. Areas of high pressure, there are no storms that are associated with that. You'll see that your fronts are only attached to your pressure systems, your low pressure system. You'd never have a front that's attached to the high pressure. When you have this air that's descending, okay, it's pushing down, and now you have cold air that's warming up, and it's not going to make clouds, right? It's just when warm air rises and cools off, that's when we get the clouds. And that's what's happening in this area of low pressure. Remember, we have the warm air rising, and that's why you see what's in green here. This is precipitation. So around this area of the cold front right here, we actually have some precipitation that's occurring. In front here, there's no precipitation. It's going to be warmer on this side of the warm front than it is on this side. It's going to be colder air on the back side of this cold front than it is over here. You can see as this cold front is coming through, it's causing this air up here to rise, and it's causing the storms to occur. And the storms for the cold front are going to occur right along the front of it, and then it can also occur right along the back of it. This one you can see that the temperature differential happened for a longer period of time, and so there must have been a lot more moisture in the atmosphere because it continued to rain. So what we're going to do is, at this point I'm going to have you guys pause the video. There are maps that are up on the desk, and you need to have enough maps. Each one of you needs to have Each one of you needs to have 5 maps, and what we're going to be doing is we're going to be tracking some of these high and low pressure systems across the United States. So go ahead and pause the video and get your maps passed out. You can have one person from each row get the maps for the row. Alright, now that everybody has your maps, you need to have the colored pencils as well. So if we need to stop again, sorry, I should have said that before. We can stop again, and you need red and blue colored pencils. Alright, now that you have your red and blue colored pencils, what you're going to be doing is you're going to be tracking what I'm circling. So you need to track this high pressure, this low pressure system, this one here, and this one here. Those are what you're going to be looking at, and you're going to be watching as they move across the United States. You need to do the fronts that are associated with them. So you're going to draw this warm front and this cold front, and you're going to have the fronts that are associated with this low pressure system as well. So what you're going to do is you're going to draw them in on your map of the United States, and then once everybody's done, then we'll go to the next one. So what I'm going to have you guys do is you're going to pause the video here until everybody's ready, and then you can play it again. So on our next map, you can see that this area of low pressure, this is at 6 p.m. Please make sure that you've labeled your maps. So this map, your first map was 6 a.m. on February 21st, 2009. Your second map now is at 6 p.m., so now we're looking at 12 hours later. So this low pressure, area of low pressure didn't move a whole lot, but you do have some movement over here. So you still have your 2 highs. Your high over here is now out over the ocean. Your area of low pressure has moved. It's now on this side of the Great Lakes, and you can see that there's a lot more rain that's occurring now as this area of low pressure is moving through, and we have this cold front coming through. Go ahead and pause until everyone's finished drawing this map. Our next one is on February 22nd at 6 p.m., so now we're looking at 24 hours later. So you can see this area of low pressure has moved. It was down here before, and now it's moved up in towards Maine. Our area of high pressure is now off our map over here. So now we have 2 areas of high pressure, our low here and our low here. So you need to have in your cold front, your warm front, cold front, warm front. Our last one is on February 23rd now at 6 a.m. So we're looking at 12 hours later again. You can see that the area of low pressure has slid up now. It's up in Canada. This one's almost on coast. So it's actually been moving sort of in this direction. And this one was a big rainstorm, and it actually did come all the way into Arizona when this one occurred. So once again, you're still doing this low pressure and the fronts that are associated with it, the two areas of high pressure, and this low with the associated fronts. We talked a little bit about isobars before. We talked about being like a topographic map and looking at where is it, the wind speed and how close together are the isobars, and that reflects on your wind speed. So the further apart your isobars are, then the less the wind speed. The closer they are together, the windier it is going to be. So on this one, when we look at how windy is it, so if you were to guess, how windy do you think it would be in here? And what I want you to do is on your notes, I want you to write, or you don't have this on your notes, never mind. I just want you to think to yourself, is this going to be really windy or not very windy? And why is that? And if you thought that it would not be very windy, you'd be right, because the isobars are really far apart. It would be a lot windier over here where the isobars are closer together. On this map, you see, okay, it's really windy over here, right? Around this whole area of low pressure, we've got lots of windiness. You can see that wind is mostly associated with areas of low pressure, and over here, as it's calmer, those are areas of high pressure. You're going to hold on to your maps. What I want you to do is I want you to, you can pass around the staplers. I want you to staple your maps and your notes, and I want you to staple them into your workbook, either on the back cover or near the notes that we just finished yesterday. These are going to be your reference sheet for the activity that you're going to be starting tomorrow, which is the weather forecasting activity.